Hello everyone. So the previous video we have discussed about unsupervised machine learning model. So in this video, right, we'll discuss about NLP text and sentiment analysis basics, right? So I want to get into deep. I don't want to get deep into NLP and sentiment analysis. My focus is to convey the basics of NLP text and sentiment analysis so that you can implement any NLP models or text and sentiment analysis models, right? So NLP, what is NLP first? So NLP stands for natural language processing, right? Natural language processing is the approach to process human languages, right? Human languages. So text to speech or speech to text conversion, translations, right? One language to another language. So all these kind of analysis or processing will be done using NLP methods, right? NLP algorithms. So it's a subfield of artificial intelligence, right? That refers to computational approaches to process, understand, and generate human languages or conversions, right? Example, you will be using a lot of voice controlled devices like Amazon's, Alexa's, Apple's Siri to utilize the NLP to listen to user queries and find the answers, right? So another thing is we have a large volume of voice and text data from various communication channels like YouTube, emails, right, social medias, right, video, audio, database, websites, right. So there are multiple NLP algorithms are also available to analyze, right, to find the insights about text data, right, text data, right. So why do we call it as NLP, right? Why don't we call it as simply language processing model, right? One may ask why it is named NLP, because, right, in order to differentiate the formal languages from human languages, right? So all the computer programming languages are called as formal languages, right? Formal languages. So if you want to differentiate the programming languages and human languages, right? Human languages, it is termed as NLP, natural language programming, right? So the natural here to differentiate the programming languages or formal languages, right? Formal languages. So all the programming languages such as C, Python, Java, JavaScript, JSON, etc., all are defined as formal languages. So to differentiate the formal languages from human languages or natural languages, we call it as natural language processing, right? Natural language processing. So as human, we don't have any formal way of generating the text or speech, right? So we generate natural language with errors or ambiguity in the data, right? So how NLP is related to AI? See, if you look at the diagram, see, part of the NLP is overlapped with the machine learning and deep learning models, but most of the NLP is not overlapped with the machine learning and deep learning models. So that means we can implement NLP, right, with the help of machine learning models, but you cannot implement all the NLP algorithms with machine learning models, right? So, but it is a subfield of artificial intelligence, right? So it can be implemented, part of the NLP models, algorithms can be implemented using machine learning models, but most of the NLP algorithms are not overlapped. So which means the entire NLP models or algorithms cannot be implemented only using the machine learning or deep learning models, right? So it needs more leveraged algorithms to implement the NLP process, right? NLP process. So why do we need NLP models, right? Because NLP is still booming, still increasing. The number of algorithms that are being uh, generated day by day is increasing, right? And the people, those who are using NLP applications like say Amisha, Google Assistant are also increasing, right? The translation work is also increasing one. The second reason is the ever-growing need for NLP algorithms, right? More sophisticated algorithm is still required for NLP, right? The final reason is it's challenging, right? Because it is very difficult, right, and complex one to convert text to speech or speech to text, right? And to process human languages without any errors, right, without any ambiguity is also very challenging one. So uh, the objective of NLP task is to improve the accuracy and performance, right? Performance. So how NLP is used in real-time applications, right? So with knowingly or unknowingly, you are dealing with a lot of NLP applications in your day-to-day life, right? Day-to-day life. So think of voice-controlled applications or social media sites. All are supporting voice-controlled assistants, right? Assistants. So you can post a photo or you can search for a particular user, right, using your voice, right? So in order to do that, we need sophisticated NLP models so that the user can make use of the application, right? And companies also will need to deal with text in one way or the other for industry or to find the insights about the data users, right? We need NLP algorithms. So NLP applications again is a software application that the main purpose is to process the natural language text and to get insight into the data, right? So there are different types of NLP applications: machine translations, right? Grammatical error and spelling correction. We are using number of online and offline grammatical error like Grammarly, Turnitin, right? Spelling correction tools, small PDF, search engines, Google, Yahoo, right? Blinken, Dialog systems, right? So the types of NLP algorithms, basically there are different types of NLP algorithms, but the most popular types are rule-based NLP, machine learning-based NLP. So rule-based NLP based on linguistic rules. It will follow strict linguistic rules, right? This was really used in the early development of NLP, but still we are using rule-based NLP algorithms. The second one is the most popular one, machine learning-based NLP models. Right? It will follow a statistical methods, so using the combination of machine learning, deep learning, neural networks to find the similarities of text to text data, right? So the techniques and methods of NLP. What are the techniques and methodologies used in the NLP? So syntactic analysis, semantic-based analysis are the two main techniques. So both syntactic and semantic-based analysis will do any of this, will do any one or more than one of these techniques like parsing, word segmentation, sentence breaking, morphological segmentation, stemming, word sense disambiguation, named entity recognition, natural language generation. Right, we'll discuss of these techniques, right, one by one. So pre-processing techniques. So for machine learning as well as for NLP, we need to do some pre-processing methods, right? Pre-processing involves preparing and cleaning the data. So what are all the preparation process and cleaning methods used in NLP? The first one is tokenization. Then stop word removal. So tokenization, you have to break the sentence into words, right? You have to break the sentence into number of words called tokens, right? Tokens. Then you have to remove the stop words like singular words, right? They don't have any useful meaning in the sentence, so you have to remove all the stop word removals like one, on, the, my. So the plural subjective words, singular plural subjective words, and other stop words will be removed from the sentence. And then you have to find the root of a word, right? Root form of a word. That is called lemmatization and stemming. Then you have to assign the part of speech tagging, right? The tagging is nothing but POS tagging is nothing but whether the word is noun, adjective form, right? Plural form, right? Pronoun. So you have to assign the part of speech tagging. Then you can do the NLP task, right? So finally you can perform the NLP task, that is text classification or parsing or text generation. You can do a lot of things with the help of NLP applications. So NLP applications is not a single process, it's a highly iterative one. So you have to do a lot of research, development, operations. See, the research means here you have to collect the data, right? Analyze the data set and experiment it with the NLP process, right? And train the model with the NLP algorithms and then implement, deploy it, monitoring for continuous improvement, right? So the structure of NLP application is basically as two infrastructure. One is training infrastructure and serving infrastructure, right? So training infrastructure, the train data set, previous data set will be used to train the NLP model, right? The serving infrastructure is used for new data instance, right? So whenever the new data instance is available for prediction, then the serving infrastructure will be used to predict the class of the new data set, right? So there are a lot of real-world applications, include the feedback analysis, customer surveys, automatic translation, academic research analysis, healthcare predictions, right? Plagiarism predictions, language writing, right? Or research analytical writing, spam detection. All are the examples for NLP applications, right? NLP applications. Text mining is another area where the NLP is used drastically, right? Right, you have to pre-process the text before predict it, right? Cleaning, tokenization, right? Word frequency, co-location, concordance. These are pre-processing methods before applying the NLP models. So we'll see a simple example how to clean a data, right? Or pre-process the data before predict the class of a text, right? So here I have taken a simple input. So this is my input data. It consists of, hey Amazon, my package never arrived. And also it consists of some URL links and some unwanted data and stop words, right? So we need to perform the most basic text cleaning techniques on this query before process it, right? So first one is normalize it and remove the stop words, right? So normalizing text. So normalizing text here means all the letters will be converted into small letters, right? Small letters. So here becomes the H, capital letter will becomes H, small letter. Similarly, all the capital letters will be converted into small letters. So the input data will be normalized into small letters. Then the unwanted URLs and stop words will be removed, right? The HTTPS, the URL and the stop words, my, right? The Amazon help, reference, links will be removed from the text, right? And then stop words, right? Stop words, hey, right? My, right? Please. These are all stop words which doesn't convey any useful information. So all the stop words will be removed. So finally we'll be getting Amazon package never arrived, fix as up. So this is the final output. Then you can tokenize this sentence. So using the space, you can tokenize you can break the sentence into number of tokens or words, right? Amazon will be token number 1, package token number 2, never token number 3, 4, 5, like this. The sentence will be broken up into number of words, right? We have actually two types of tokenizers. One is word tokenize, another one is sentence tokenize. So word tokenize, using the space between the words, you can tokenize it, right? That is the basic one. Whereas the sentence tokenize, using the dot, the entire sentence will be considered as a one token, right? Using the dot, the entire sentence will be considered as a single token, right? But most of the NLP algorithms is implemented using the word tokenizer, right? So you can tokenize the sentence, you can break up the sentence using the word tokenize, right? Then you can assign the POS tagging. So POS tagging is to find the root form of particular word, then assign the tag for it, right? See, whether it is noun or verb or adjective adverb or whatever it is. So if it is a noun, the tag is n. If it is a verb, it is that POS tag for the verb is v. For adjective, it is adj. Like this, you have to assign the tag for all the words. See, we have tokenized all the sentences, Amazon package never arrived, fix as up. So these are the tokens which has to be assigned with the POS tag, right? So Amazon, so JJ, right? Package noun, never, root, right? Arrived, verb, right? Then fix. These are all the POS tags for the words, right? Then you can apply the NLP algorithms after finding the root form of a words, right? So keyword will be retrieved, and then we can apply NLP task for predictions, right? So whatever you want to predict. So the predictions, before predicting the class of text, there are various methods are also available for finding the final class, right? So instead of using a single word to predict a class, we can use n-grams, right? N-grams. So n here denotes the number of words you will consider for prediction, right? So whether you are considering a single word or a group of words, 2, bigram means n equal to 2, trigram means n equal to 3. So n-grams are, if you increase the number, instead of considering single word, if you are using 2 or 3 words for prediction, then the accuracy will increase, right? Because most of the words are dependent words, right? Dependent on 1 or 2 words. So if you use bigram or trigram models, it will improve the results, right? So we'll see a simple example for n-grams. Say I have taken a sentence, the cow jumps over the moon, right? The cow jumps over the moon. This is the sentence inputted to a NLP model, right, after cleaning. So if you are selecting n equal to 2, known as bigrams, then the number of n-grams will be the cow. 2 words will be considered as a gram, bigrams, right? So the cow jumps over the moon. So these are all the bigrams generated using the model, right? Using the model, then you can assign the part of speech tags for these n-grams, and you can find the important bigrams out of this, and I can apply NLP to predict the class, right? So if you are choosing n equal to 3, then the grams would be this right? So the basic formula to calculate the number of grams is equal to n grams is equal to x minus n minus 1. So here the x is the number of words in the sentence, all right? Number of words in the sentence, that means in this case 3, 4, 5, 6. 6 minus n minus 1. If you are selecting n equal to 2, 2 minus 1. So 6 minus 1, 5 sentences you will be getting. See, for n equal to 2, you will be getting 5 n grams, right? For n equal to 3, you will be getting 4, right? So applications, the NLP model can be used for sentiment analysis, right? Named entity recognition to identify the entity for names, locations, organizations, right? Text classification, topic modeling, and language generation, right? Language generation. So the next video, we will discuss about the basics of time series analysis, right? So I don't want to get into deep about NLP algorithms because it's quite difficult for you to understand. So if you have any questions or further requirement, just put it in the comment box. I will discuss in the next videos. Thank you everyone for watching my video. Thank you.